Hello, good afternoon everyone, and welcome to our latest webinar, Solving the Public Safety Communications Puzzle, where we will discuss the present issues in public safety communications with focus on in-building communications. I would just like to introduce our speakers today. So we have John Drucker, who's the product manager for iBwave Unity. John is an expert with over 15 years of IT project management experience, and at iBwave, he's the force behind iBwave Unity solution that helps companies in the wireless space execute their projects with greater ease and accuracy. And we also have a special guest speaker today, Brian Kemper. Brian is the managing partner at HetNet Wireless, which is a leading consulting company for improving in-building wireless coverage, specializing in first responder radio coverage design, testing, and system monitoring. Brian has over 15 years of telecom experience. He has developed business strategies for emerging technology companies. His last venture concluded with a successful acquisition by Solid Technologies. Before we get started, I have just a few housekeeping items to mention. You will be receiving the slides and video recording of the webinar by email in the next few days. So keep an eye out for that. And also during the webinar, if you have any questions, please feel free to type them in the questions box provided by GoToWebinar, and we will get to as many as we can during the last few minutes of the webinar. And without further ado, I will hand it over to John, who would introduce iBwave a little bit.
Thank you very much, Amna. Welcome to all who've dialed in. We really appreciate you taking the time. As Amna said, my name is John Drucker, and I'm responsible for the iBwave Unity solution. And today we'll be talking about the public safety aspect of it as it relates to the tools and the how-to, and we'll also be giving you a lot of information on the practical aspects of what to consider. And Brian Kemper will take a long tour through how we get through these different codes and the things we have to consider when designing for public safety in this particular market. A little bit about iBwave, for those of you who don't know us. We are the worldwide standard for in-building documentation and design. We are a technology leader in this area and have been for 13 years. We are trusted by over 800 customers globally in 87 countries, and we are the indoor wireless standard. So when it comes to design, when it comes to your mobile, your wireless, your Wi-Fi, we are the place to go to help you execute your projects. So I'd like to just go through the agenda very quickly. We'll give you a little bit of an introduction. Brian will give a bit of an introduction about himself and HetNet, and then we'll go into the fire and building standards in a little bit of detail. Furthermore, we'll touch on the emergency responder radio coverage requirements because these are very key to understand. After that, Brian will go into the main phases of the design planning aspects, such as testing, permits, installation, commissioning. This is very important for this aspect of how you actually roll out your work. After that, I'll cover a section about our iBwave tools and how they support this process and how we're giving you a solution not just to do the design, but to enable everything from the testing all the way to the commissioning and acceptance. And lastly, we'll get to the key takeaways. Brian and I will cover what it is you should pull out of this webinar so that you can use for your daily work and what to think about. And without any further ado, I would like to hand over to Brian Kemper, our friend and colleague of many years. Brian is on the West Coast, so it's his morning. It's our afternoon. And Brian, please take it away.
Great, John. Thank you very much. Thank you for everyone for joining us on the webinar this afternoon. I'll try to refer to this afternoon as much as I can, but as John said, I'm here in the Bay Area in California. It's just a word about our background. For the last 15 years or so, I've been in the in-building wireless industry with distributed antenna systems. I ran a system integration company called Tripower for a while, and was also involved with the launch of Solid USA for about 7 or 8 years. And then, as I'm going to refer to earlier, we completed a successful acquisition of the Koreans of Solid Technologies, buying the organization earlier this year. And after that deal was done, I was looking at the industry and saw that there was definitely a need for a wireless consultant for DAS and for first responders, providing just professional services. So that's why we launched HetNet a couple years ago. We're purely professional services, doing consulting work and design for For integrators, oftentimes we're also hired by integrators to do third-party testing. In some ordinances in some municipalities, a third party is required for the testing, and we do that work as well. But we are extremely passionate about in-building wireless. We certainly help with carrier enhancement, but I would say 80 to 90% of most of our projects are primarily focused on first responder enhancement, helping the local municipalities and developers and contractors and public safety agencies try to get our hands wrapped around this emerging need and bringing it all together. Also introduce and would be glad to connect with anybody on LinkedIn. Feel free to search for me and shoot me an invite, and if there's anything that we can to continue the conversation after the webinar, I'd be glad to do that. So this afternoon we've got a couple things we're going to do. I'm going to talk about a couple driving forces as far as the industry that we've seen over the last 10 years, and then we're going to dive a little bit deeper into the codes and regulations that we have, and then just a few ideas which I'm sure you guys are very familiar with as far as the processes of actually going from the beginning to an end with in-building first responder systems. But the first idea is the fact that we just see technology impacting every aspect of our lives. We just see it. You know, we don't even realize how much technology has evolved and affected us, but it's everywhere, whether it's in our homes or dealing with our kids or our friends or communicating, or certainly in the workforce. We see all these things taking place, and particularly with in-building wireless, there's such a drive with new technologies, whether it's the old school repeaters and coax and antennas to distributed antenna systems and fiber-based systems that we've had for the last 15 years or so, and now with small cell and all of the arguments and conversations. All right, do we put multiple carriers on one system? Do we put first responder on the system? How do we deal with small cell? How do we deal with all of the different technologies coming together? And we see those things coming. And one thing that I've experienced over the last 15 years is there was such a push, probably 8 to 10 years ago, of putting everything on the same system. And some of us can even confess that we've gone through the pain of actually even having Wi-Fi on a system at one point. So we've gone through that push, and now we're seeing more of a separation of the systems, particularly between first responder and the wireless carriers. And I think that's being driven primarily due to the code and some of the requirements that are necessary for first responder, that we don't have those requirements for the wireless carriers. And we're just seeing kind of an economic push that it's actually less expensive to have two different systems than it is to have one system because of those requirements. So we're certainly seeing a lot of technology changes that's impacting our industry. And then the second driving factor that we're all experiencing as well is just the building standards, right? The building standards have changed and become so much more stringent over the last few years that it's been great for energy efficiency. Like, there's a ton of lead going into the glass now of the windows of the glass that's being installed in new buildings, and it certainly is a benefit to the environment, less impact on the environment as far as decreasing the amount of energy requirements. But as far as wireless is concerned, we've all seen that it has definitely been a huge disruption in not getting adequate coverage from the macro sites coming into the in-building. A few years ago, I don't know, probably about 6 or 8 years ago now, we were working with Rady's Children's Hospital down in San Diego, and they're the cell site less than a quarter mile away. And on the top floors, right next to the glass, we had probably neg 85, maybe neg 75 in some areas, and then we were just walking 10 or 15 feet away from the glass, and we were probably having anywhere between a 25 to 30 dB hit, and the phones just weren't working at all. And this is typical for many new construction sites, even with cell sites very close to the building, that we're not getting adequate coverage from the outdoor network. Now, the advantage of that, obviously, is we're able to avoid a lot of the pilot pollution, and we don't have to worry about a dominant signal coming in from the outdoors. So we're able to design much more efficiency, and our designs are much better now that we're able to take care of each of these buildings almost like a Faraday cage, in essence. So we see that. We see the technology changing. We see the building standards definitely affecting our industry, which brings us to the topic that we're talking about today as far as first responders and how do we protect those that are keeping us safe. One of the very first projects I was involved in, this is back in 2004, and there was the Bellevue collection up in Bellevue, Washington. And we came across the opportunity, and at that point I hadn't done any first responder systems at all. But I was looking at the frequencies. We had done a ton of Nextel, IDIN, push-to-talk systems, working with them. And I looked at the frequency and said, how hard could this be, right? It's the same, practically the same frequencies. Let's see if we can do that. And in the course of that project, I remember hearing a story of one of the fire marshals or inspectors relating it back to one of our team members. And the developer was having a few issues with the expense of the first responder system. But the fire marshal's response was, you got to keep in mind that when you're running out of the building, it's when we're running in the building. And that kind of struck me. It's like, this is not just about improving communications for cell enhancement. That type of topology is generally a one-to-one. Sometimes we might do group texting, but for the most part, we're texting to one person, we're calling one person, and those communications are relatively limited into one-to-one. But when we're talking first responder, we're talking one-to-many. And so there's one person needing to talk to many people to be able to keep not only them safe, but also the property safe within the building that they're trying to protect. And so it becomes very important that we do our work well, that we do it right, because 99% of the time the systems that we install will not be operating at all, and it's absolutely crucial and critical that the 1% or the 0.11% of the time that they're needed, that they actually do work. So since that time, we're seeing a lot of new emergency responder radio coverage requirements. A lot of mandates and ordinances are now being enforced. And as you see on the next slide, it's going to remind us that we have both mandated and regulations and standards that are coming across all over the place. And one thing to keep in mind along this path is, even though it may be regulated, it may not actually be enforced. And so we're going to get to that in just a couple slides as far as the International Fire Code and NFPA 72. But one thing to keep in mind is that just because it's being mandated and regulated in a code doesn't necessarily mean that the local jurisdictions or the authorities having jurisdiction of a local municipality or city are actually enforcing it. And that's where the conversation has to begin. What does the code require, and what within the code is actually being enforced by the AHJ? And I get this question all the time by clients and consultants and contractors and integrators, like, how do we figure that out? Well, there's a few things that we're going to see from the nationwide codes, but ultimately what it comes down to is you have to have a good conversation and a good relationship with the fire prevention office, either at the state level or primarily at the local level, and just ask them what is currently being enforced. And I think there's a huge market opportunity for many contractors out there simply by picking up the phone, asking the fire prevention office what's being enforced, and if they have a particular nationwide fire code that they're using, they may actually already have the code, but they're simply not enforcing it. And then that brings the opportunity in the discussion is, why are you not enforcing it, and what can we do so that it can be begun to be enforced, particularly with new buildings and new construction projects. And this isn't the first time that it's affected fire prevention and protection. Really, if we look at it, smoke detectors and sprinkler systems went through this same huge explosion of growth about 15 or 20 years ago. And it's amazing how similar first responder radio coverage is actually to a sprinkler, right? So in a sprinkler, you've got pressure, you've got water, you've got pipes, you obviously have the sprinkler head where the water needs to come out. And if you think about it from a design perspective, it's very similar to first responder in the sense that we've got signal boosters, we've got repeaters, we've got antennas, we've got coax running those antennas, and instead of water coming out, we've got RF. And yet we're still dealing with propagation modeling tools to figure out how far the RF can go and how many antennas, in that case, how many sprinkler heads there were in the back in the day as far as installing it. Now, obviously, what makes it more difficult and more trying is water, right? It doesn't change much. But with RF, we have all kinds of different frequencies, low band frequencies, 150, 450. We've got trunk systems, and now the P25, and now even as we're trying to go to FirstNet as well. So there are certainly a level of complexity that we experience with first responder coverage that they didn't acknowledge and experience there with the sprinklers. And I would say, you know, as I go through the presentation, by all means, send on any questions that you have. I'm trying to give a fairly generic overview of the industry. I'll try to dig down a little bit deeper so that you get some technical aspect from it as well. But by all means, shoot out some questions. We'd be glad to respond to those questions after we get through these slides. So as far as the standards are concerned, you'll see on the next slide there's a few different organizations, obviously, that are driving it. We don't have an ubiquitous network for first responders. Certainly that's the idea of FirstNet, as it has received, I think it was an original $7 billion of funding from Congress to get that going. They are beginning to get their work done. I think as of yesterday, I looked on their site, I think they have 14 different governing boards that have now been established. So they're beginning to have those conversations with the local agencies and certainly with the RFP coming out as well, and people responding to that. We'll see how that happens. But for the most part, first responder coverage has been very fragmented for the United States, and it's something that's trying to be rectified. And certainly from a nationwide level, we've had two primary codes that have dictated and help us with those regulations. And as you see on the next slide, I've got both the NFPA 72 listed, and I also have the IFC listed as well. And so depending on what state you are, generally it's going to fall under one of these two nationwide codes as far as what's being enforced. And then I would reference one of our resources that we can provide for you. If you go to our website at headnet.com, you'll see on our blog site that we've listed every state, and we've tried to determine which of these codes is being enforced for the state. Some of the links may not be the most up-to-date, but generally there's a link not only saying which of the codes that the current state is enforcing, but it'll also give you a link to the particular fire prevention board site for that particular state, and hopefully you can get some more information there as well. And I'm going to take a few minutes here and dig a little bit deep in the weeds as far as these codes are concerned. I apologize if I'm boring you by any means, but it does get a little bit confusing as far as what the codes are doing. So for NFPA, there's both the 2013 code and now the 2016 code is coming out. And for the International Fire Code, it's section 510, and that was both in the 2012, which was the first time that it was released, and now it's also been released for 2015. The IFC is fairly straightforward. There weren't any radical changes between 2012 and 2015. There's some grammatic things, you know, for one, they refer to it as standby power in the 2015 code as opposed to the 2012, it was originally secondary power. So for the most part, there hasn't been a whole lot of changes in the IFC. However, in the NFPA, there's been significant changes coming from 2013 to 2016. Originally in the 2013 code, it was all found in section 24 on NFPA 72. In the 2016 code, it's gone from section 24, and now you're going to find it, excuse me, in section 1221. So it's a completely different code. The NFPA 1221 is now referring to all the requirements that are necessary. And there's just a few things that have been significantly changed. Isolation has now gone from 15 dBm to 20 dBm from the donor antennas to any remote antennas inside the building. It's also requiring system component failures to be modified and to be monitored, not just the repeaters. And it also is now specifically stating that 2-hour rated vertical enclosures are now required. So you'll see some of those differences in the NFPA 72 from the 2013 code to the 2016 code. And obviously it takes quite a while before the current codes are being enforced. In fact, some states are still going back even as late as 2009. And I can't remember one of them, but it was one of the states in the South, either Alabama or Mississippi, I can't remember which, is actually referencing a code that was written in 1972. So it just shows us how fragmented the industry is as far as these codes are concerned. These next slides, however, highlight a few things that are consistent between both the IFC and the NFPA 72 as well. And the first one is actually one of them that's very often overlooked, and from my estimation is actually probably the most important thing to keep in mind when you're doing a first responder system. And that's the fact that a construction permit is absolutely required when you're doing an emergency responder radio coverage system. It's absolutely essential that we go through the design and the building permit submittal for the permit. And the reason why this is important, obviously, is first of all, we're making all of the agencies aware that a repeater of some sort will be installed within the system. And it's also very important as far as making sure that you're able to know what your costs are and to understand here exactly what we're doing with the authorities having jurisdiction. The last thing that you want to do, particularly in a construction project, is have this entire system designed and ready to implement, and then 6 weeks before we're trying to get the temporary certificate of occupancy, some other requirement is come up. If you do your due diligence and you document exactly what the system is going to enhance, and it's all within the design permit package that has been not only submitted but approved by the AHJ, then at least you have the argument to be able to go back to that design submittal and say, this is what we agreed to. Can we at least have a variance after 6 or 9 months, whatever it is, to be able to modify any changes that need to be done. And from contractors' perspective, this is very important as well, because at least you're able to acknowledge to your customer, whether it's a general contractor or an owner, saying this is what we agreed to do, and this is what the AHJ has approved us to do. And if there's any modifications or changes to this particular system and design, then at least we can talk about how we're going to take care of it from either from a change order perspective, or how do we deal with the AHJ and being able to take care of the needs that they're now requiring. So the first thing is the permit. Absolutely get a permit. It's required by the code, and it's absolutely the best practice as far as installing these systems, whether it's a new construction or an existing building as well. Another requirement that we see, and very straightforward, is the signal strength, right? So neg 95 is consistent both for the IFC and NFPA as well, both neg 95 on the uplink and downlink, going back and forth. Again, the NFPA is the one that addresses isolation, which is extremely important, obviously, in our design. So it's important that we're balancing sufficient signal strength readings, but that we're also having enough isolation between donor and remote, that we're not creating any uplink noise that goes back into the macro site for the public safety agencies, particularly for simplex systems, right? So 700, 800 is fairly straightforward on any P25 digital trunk systems. Even the UHF is fairly straightforward in 450, but when we start getting into the low band 150 VHF simplex systems where we're having separate transmit and receive antennas, that's when we need to be very, very careful. And what we're seeing is on a lot of new construction projects in particular, we're seeing a very high level RF noise floor. And in fact, we had one project that it was just absolutely driving us nuts. And finally, we were able to identify the fact that the noise was actually coming from the ballast of the fluorescent lights that were in the parking garage. And so when we realized that, then obviously we needed to be able to design correctly so that there were enough transmit and receive antennas so that we were able to have the separation between those and we weren't creating the interference between the antennas coming back out to the donor antenna. So even though it's old school and it's been around for a long time, there's always new nuances that are affecting how we design and the best practices for the systems that we're trying to implement. So signal strength reading, obviously isolation between the donor and remote antennas is extremely important, and then having enough padding and filtering so that, always keeping in mind that even though we're trying to enhance the coverage for a particular building, we also need to be very careful that we're not creating any negative noise coming back into the macro site, because the last thing you want to do is affect a macro site that doesn't only take down the building coverage of the building that you're working in, but all the surrounding buildings and all the surrounding area and the outdoor as well. Hence the reason that the FCC has been very stringent and very clear that broadband repeaters must be registered with the FCC so that they know exactly where those sources of possible interference are coming from, and that they can be dealt with in a very quick time frame. The next slide shows secondary power. So we've dealt with the coverage area, the permit, we've dealt with the signal strength. Here we're dealing with secondary power. And this is not an insignificant factor when you're dealing and thinking about the cost of first responder system. We had an apartment complex here in California, and they had originally put in a 150-450 system. The city, literally 6 months after occupancy, goes to a 700 trunk system, and now is requiring all the developers that had installed systems to reband to 700. And in the midst of going to the 700, their ordinance became more stringent, and it was now requiring 24-hour battery backup. And so the overall cost for them to go from the 150-450 system to 700 was relatively small. It was only about $60,000, something like that, for the repeater and some of the antennas that was necessary. But for them to meet the 24-hour battery backup, because the cell carriers and the first responders were on the same system, they were required to do 24-hour battery backup at every remote location. And it wasn't a hospital, right? So hospitals generally have the secondary power. That's not a problem. But in this particular case, it was an apartment complex which had very minimal secondary power. And so they literally had to put 24-hour battery backup at every closet that had every remote unit for first responder and cell phone. And the cost of doing the batteries was about 3x compared to what the cost was simply for adapting for the 700 trunk system. So secondary power actually needs to become a fairly important discussion point when you're thinking about design. It may be better to have a centralized location with one signal repeater, one booster. That way you have all of your secondary power at one location, as opposed to spreading out in a fiber DAS where you may have to add additional secondary power. And not only that, but you're also adding additional points of failure when you go that approach. So you need to be very careful. Obviously, in larger campuses and facilities, sometimes the fiber DAS is absolutely essential, and we have to deal with it, but it is certainly something that we have to keep in mind. And the next slide, which is the last point that I'll bring forth as far as the ordinances and regulations are concerned, deals with the testing, right? So upon completion of installation, the building owner shall have the system tested, and there's a minimum of 90% coverage area per floor. So it's 90% for the coverage area, and NFPA now 1221, it also states that all critical areas, stairwells, control panels, et cetera, must have coverage of 99%. So even though you may be designing a system for 90% coverage, and sure enough, maybe 2 of the grids fail, non-adjacent grids fail, but it still passes, the AHJ can simply come out and say, you know what, I don't have adequate coverage in the stairwell. You absolutely have to give me coverage here for us to pass it. So it's important to have those conversations early on, identifying all those critical areas and making sure that we're overly designing in those areas so this does not become an issue. The last thing you want to do is deal with one area that doesn't have coverage. The developer is trying to get their TCO, and it's being hung up because we don't have one antenna next to the control panel. That's very difficult, very hard. There can be all kinds of damages, delayed damages, which can be in some contracts as well. We have to keep an eye on that. And the last thing you want to do is start having an argument with a fire inspector that you're meeting the 90% because you're way better off just running another 50 or 100 feet of coax with an antenna and calling it good. So it's very important that you identify the critical areas. It's important that we know that there's 90%. The grids are laid out, 20 grids right per floor, and you're able to have only 2 grids fail as long as they're not adjacent. And then if more than that fail, you can go to a 40 grid test. And then if that fails as well, then some type of modification is going to be required for that particular floor. So those are the things I highlight as far as the ordinances are concerned: the permit, the signal strength, the secondary power, and then also the necessity of making sure that we have 90% coverage on each floor as it's being tested. So let's talk a little bit of how we do it. That was kind of the why we do it or what needs to be done. The next 2 slides is kind of how we do it, best practices. Again, we're a professional services consulting firm only, so we do testing for contractors if they need it and for others as well. You see on this slide a particular plot that we did for Sunnyvale. They had installed a system for a 150-450 public safety system, and then they were migrating to 700. So we did some testing for them, and as you can see from the slide, that it was very strong on the 150-450 on the west side of the building. Obviously, that's where the transceiver is. And then by the time, that was on the west side, and as you got to the east side of the building, it was failing. And one thing that I'd like to highlight is remember that the regulations and the ordinances require coverage. They do not require a system, and that's really important. At the end of the day, we need to make sure that we have coverage, not necessarily that we've installed a system. If there's adequate coverage coming from the macro network, then everything is fine, and we can provide that value to our developers and building owners that they can save money by not installing a system when it's not necessary. But in this case, when we only have a floor, a third of the floor, if that's not passing, then really the system only needs to be installed on the side of the building that need it. So in this case, obviously, enhancement for 700 is only required on the east side of the building, and again, we're able to decrease the amount of cost that a developer or an owner would have to expend to meet those requirements, because again, we have to meet coverage. We don't have to meet a particular system. In construction, though, this becomes very difficult, right? So how do you determine when to test the project, and when do I have enough time after the project has been tested to know whether I can get the lead time for my amplifiers? Especially in the low band frequencies, everyone knows from experience that the lead time for low band frequencies is very high. So ideally, we want to design the entire system at the very beginning of the project before installation even begins. That way the developer and general contractor know what their budget line item is, they know what needs to be done, and they can either begin to proceed right away during construction, not worry about testing, maybe at least get the passive materials in the ceilings and before everything gets closed up, and then deal with the active equipment later. But certainly we need at least 12 to 14 weeks lead time for some of that equipment. And so before that ceiling is being closed, then the initial testing can be done to see, do all the floors need enhancement, or is it just some of the floors that need enhancement? Again, it's very difficult to balance the two between a construction timeline of making sure that we don't interfere with what's taking place, along with making sure that we meet the code's requirements from the AHJ so they actually sign off on it and the developer is able to occupy the building. So if we're able to do initial testing, certainly on an existing building, that's very straightforward and very easy to do. On a construction project, it becomes a little bit more finesse is required. But after we've done the testing and we have established that some type of enhancement is necessary, then we go into design for the building permit. As you see on the next slide, here's just a screenshot of the single line diagram of one of the designs that we've done. Very straightforward, right? You got the donor antenna on the roof going into the signal booster there at the MDF in the lower left-hand corner, and then we have the coax going out to each of the antennas. One thing that is definitely critical, particularly with NFPA, is that there has to be a 2-hour fire-rated enclosure from the donor all the way down to the amplifier. So oftentimes we'll see people starting to install it and they do not have a 2-hour enclosure for that pathway, and that can become very difficult and very expensive in the middle of the construction project to make sure that's done. So that's always very important. And then obviously the ability for the amplifier to tie into the control panel on the fire alarm system is essential as well. One thing I probably should have highlighted earlier, the new code for NFPA in 1221 now has 7 points of alarm that are required. In the old code, there was only 5 points, and probably the most significant one is that all of the system components need to have some type of alarming as well. And so in a fiber DAS system, that can become a little tricky, and so you have to keep that in mind as you're looking at it. But again, it's taking the iBwave design. We use iBwave for propagation modeling, so we can figure out where the antennas are, where the BOM is. All of those things are very good as far as an RF perspective. And then generally what we do is we take those models and those designs, we put them into a CAD package, and then they are submitted by the electrical contractor. So whoever is pulling the permit is required to submit the design to get approval from the AHJ. And then, as we all know, rarely are they approved on the first submittal, right? So they'll come back and there will be hopefully just a few nitpicking things that have to take place. Those can be changed, resubmitted to the AHJ, and then get approval for the installation. And then after the design's been installed, or approved I should say, then we go into installation and commissioning. I've got a picture here of an underground garage. The reason that's there is that obviously if there's any garage below ground areas, in all likelihood that development, that property is absolutely going to need enhancement, and we can at least begin with the design and installation of the lower floors, and then if necessary the upper floors can be enhanced as well by running cable and antennas to those areas. Oftentimes, obviously the electrical contractor would do the installation. Sometimes they have the ability to do the commissioning and engineering. Sometimes they don't. That's one hole that we're trying to fill in at HETNET. There's a lot of contractors that will install these systems, but they may not have the engineering expertise to be able to commission it. And then we also help other integrators with their workload as well at times, being able to bring their systems online and testing it for them as well. And so hopefully the installation and commissioning goes well, and then that brings us finally to the acceptance testing, right? So we do the 20 grids per floor. We test each of those grids for the signal strength, making sure that it hits the minimum of the neg 95 dBm for signal power. And then there's also a DAQ test, a digital audio quality voice test that will be done by the radio, simply talking back to the dispatch, making sure that the voice communications are clear by the fire inspector. Obviously, you want to do all of this acceptance testing before the fire marshal or fire inspector is on site to test their radios. If you do this adequately and you have the report ready to go, and for their submittal even before they're on site, it makes their testing go very smoothly. They'll check out a few critical areas from the control panel and where they are at, make sure that their radios work. And generally, as long as there's been good communication with them from the beginning of the project, generally that goes very smoothly, and hopefully there's no gotchas here at the 11th hour. Again, we can't stress strongly enough that a building will be occupied if we don't have cell coverage, right? I've never heard of any building not being allowed to be occupied because one of the carriers isn't working. But when it comes to first responder coverage, it's absolutely required. And so it's essential that these things are taken care of. It's some things that some developers and owners aren't quite familiar with yet. I can't tell you how often I'll get a call from somebody and say, I got this DAS thing, and the fire inspector is telling me that I have to fix this DAS thing in about 6 weeks or I can't occupy the building. Those are pleasant conversations in the sense that we have an ability to help a client and a customer, but they're unpleasant in the sense that it creates a lot of heartburn and unnecessary anxiety at the very end of the project, where it's not just time, but it's also budget dollars are very scarce at that point. And now developers and general contractors are dealing with costs that they had not anticipated, and it becomes very difficult for them, but they know that they have to get it done to occupy the building. So with that, I'll hand it over to John. He's going to go through a few slides of iBwave Unity and how it's helpful both from a design and from a management perspective as well.
Brian, thank you very, very much. That was extremely interesting and fantastic detail and really practical information, especially the situations you've gone through and the really practical kind of pieces of advice. It's great for our audience to hear that. Just to continue along the line of the day-to-day and what you do, Brian raised a lot of points about best practices and what are the best procedures. And some of the things that we've come across are how you consider your surrounding bits to the actual design, because it's not just the design, it's all the phases that lead up to it. For example, with annual testing, how are you going to handle annual testing for active components in the system? If you are doing the testing, when you do your designs and you need to update a design, how will you handle that? Is it a simple way to do it? Is there a system to support you? What kind of reports do you have to provide to AHJs or other people, building owners? And are you connecting with the building owner and the AHJ as well? I mean, Brian raised that point of actually talking to these people. It's a lot of it is about the connections, not only about the design itself. And when we've had these discussions, internally, we kind of see iBwave Design and Unity and our components database together as a solution to support actually executing this and the how of what I do day to day. We know very well the standard that iBwave Design has become in the industry. It's used for small cells, for Wi-Fi, for public safety, for RTLS, and it is the central piece around this, but it's not the only piece. And we have expanded our portfolio to be able to help people in the public safety area or who perform these services to leverage the pieces that are in there for things such as acceptance testing or any of the other elements. One of the aspects that you can leverage through iBwave Design and eventually Unity, which I'll get into in a moment, is our iBwave components database. Yes, it comes with the design, but it's also your central point of control if you're working with a contractor or if you are working with a manufacturer of parts. You have the ability to ensure that your pieces, that your parts, your antennas, your cables are modeled properly and actually meet the standards. And additionally, when you're doing your design, you can, through this or through iBwave Unity, control what are the permitted parts that you can use so that designs are not put forward that may not meet a new fire code or a new standard or a new piece of equipment. So it's important to understand that it's a broad scope of things that you need to consider in this area. And lastly, as part of this is our iBwave Unity management platform. What iBwave Unity does to support this is it allows you the ability to not just update your designs, but the information that you update in the design, if you have to make revisions, is automatically extracted from the design file and put into the Unity database so that you always have the latest information should there be any type of traceability or auditing or query. So you've got a bit of a backup in that respect. Furthermore, you can take advantage of the built-in workflow. What iBwave Unity does in this case is, let's go back a second actually to the different phases that Brian showed us, where you have testing, initial testing, and then you have the design, and then you have to get acceptance testing and installation and commissioning. These are project phases that you can divide up within your Unity workflow and make sure that they're executed at the right time by the right people and the right information is pushed along to the right people. If you're working for a larger organization, a larger SI for example, it may be difficult to keep in contact with the people who you want to execute this, especially if you're working with contractors. And this will allow you to give them the information they need and also inform them through notifications as to what step they have to take at what phase. And one thing in particular that Brian raised is what happens if there are delays? Do you know where you are in your project and the financial penalties that could arise by not having executed a particular step of this at the right time? So it's not just the design and the technical aspects that Brian raised, it's also the execution thereof and what it means to protect people and also have a viable business case so you do this productively and profitably. With iBwave Unity and Design as one solution, you get to see all your sites and all your information. You can see the revisions as well to your designs to ensure that you're always working with the latest one should there be any call for that. And you can always pull up your bill of materials at any given time and submit that as well as any other documentation that you have, and you can share that very easily. So we feel that with Unity and Design and our database of components, you have a very strong set of tools to support you beyond the design but also throughout the life cycle. Because if you want, you may be continuing with a particular customer. It could be multiple projects on the same site if it's a large site. You may be there for a long time, so you'll want to be able to handle your projects over a period of time, especially as they mount. The more and more projects you have, the more difficult it is to actually react and find the information that you need. One of the things we want to drive home is that this solution will help you also protect, connect, and share with people. You are generating intellectual property when you do these designs. When you do this public safety design, you are taking photos, videos, you might have a mobile file, design file, you will have data and reports. And just dropping them into a Dropbox isn't enough. Often we'll hear, well, I can just do that, but you're not gaining any information out of it. You're not able to parse your file to be able to get the most current information from your design. And you can set up your site so that you've got your information structured the way you want. And it becomes an integral part of your workflow and your execution. Because from the iBwave Unity and Design platforms, you can communicate through the cloud to the AHJ or to a building owner very easily and ensure that the right information is passed along. As Brian mentioned before, a building owner is going to have this tested at the end. So what information will you permit the building owner to see and what can you give them easily and ensure that they have the right information at the right time. With this, we have a platform to help you pass along the information and not have to rely upon sporadic emails or not being able to ensure where you have all the documentation. So through centralization, you can connect easily to people outside of your organization and share with them so that the process happens on time so that you also get paid on time, which is another real-life consideration. And I'd like to take this one step further. One of the things that we've noticed is that public safety doesn't just end with the design, it's so much more than that. We're starting to see that there's a link with disaster recovery, and I want to get into this from a more conceptual point of view. Very often, disaster recovery planning has been, well, are my people okay, and have I backed up my servers and my files? But it's a lot more than that. What is an asset to a company? You know, forever we've heard it, you know, the people are my asset, and the objects I have are my assets, and so is my data. Like, I can't live without that. But there's one crucial aspect that has not been discussed, and we think is worth discussing from a point of a business opportunity. The public safety designs that you're doing and the components that enable that communication, you are, as designers, are taking your brain power and putting this together to make this work. This is something that helps companies, buildings, or I should say official organizations. In the event of disaster, you help them get back on their feet. And let's take, for example, the case of 9/11, which is still in everyone's memory. How do we rebuild after that? What kind of information is there that we could supply in the event of disaster that we've already designed for? And in the case of public safety, we can help rebuild things, and you have the opportunity, potentially, to have a service to your customers in the form of a disaster recovery plan. It costs a lot of money. Disaster recovery. This was a little piece of information I dug up about what it actually costs a business, and a small business, small company, of just being down, and heaven forbid they have a fire or a power outage or a flood or worse. An hour will cost them approximately $8,000 of time. So their time of getting back up to speed is critical in the event of an emergency. And this is where you can help your companies, you can help your customers, you can help local authorities get back to business sooner so people are functioning. And that goes from public safety designs to the disaster recovery. So by being able to supply information, house it, and give it to the right people at the right time, you're not just enabling safety, which is absolutely critical, but you're enabling people to get back on their feet after a disaster has occurred. And we know they will occur. They occur either naturally or unnaturally. But this is how we can plan for them, and this is how the companies that do this can actually support companies and business in their locales or in their states or in their provinces. So we think that there's a genuine opportunity to support business through disaster recovery planning with this, taking public safety to another level. You help people get back on their feet through the use of getting information to the design to the right people and rebuilding. You're rebuilding with your knowledge assets and with your skills. And you also have not just the what and the codes, but you also have the how to do these things so you can get things done more quickly and more efficiently for your own business. So let me get into the last few key takeaways with Brian. We have 5 that we want to cover. Brian, knowing your codes, what do you have to say about this as a key takeaway?
Yeah, definitely. Obviously, the code level all the way from the nationwide, whether it's IFC, NFPA 72, all the way down to the local municipalities, we're seeing that some cities, or many cities actually, are enforcing their own ordinances that are tweaking the IFC or NFPA 72. And so it's very important to know all those codes and exactly what the AHJ is requiring, particularly for new construction.
Excellent. You covered the emergency responder radio coverage requirements. Is there anything you want to just highlight here?
No, I think we got pretty well covered as far as the technology part of it. And again, knowing what the requirement is, getting the permit signed off at the construction, at pre-construction, is vital. That way everyone knows exactly what's being done.
Thank you. Brian covered the various phases, the test, design, install, commission, and acceptance. I think this is important to understand that what Brian is telling us is this is not just the design. There's an actual process that goes to this, is best practice so that you get things done at the right time with the right tools and communicate with the right people. It's very important to look at the whole pie when you're looking at public safety. With the authorities that are having jurisdiction and building owners, being able to stay connected with them and stay up to date, leverage what your resources are. If you've got design, if you've got Unity, leverage these tools to share information with the right people at the right time. It's really critical. And lastly, we feel that there is a support for disaster recovery and long-term planning through public safety. We think there's an opportunity there to really do good for your society, do good for your businesses, and help out a lot here. We think there's a great opportunity for a lot of people here to contribute through public safety designs to help their local communities. Having said all that, We'd like to open the floor to some questions. Amna, our moderator, will be happy to deliver these questions. Amna.
Thank you, John. So we have quite a few questions, actually. Let's see how many we are able to answer in the time that's left. So the first question is, what are the building design choices that can be used for passive improvement of the signal?
Right, so passive versus active, and John, I'll answer the question if you want, and you can just feel free to interrupt me, obviously. You got it. So on the passive side of it, obviously, we highly recommend passive as much as possible, right? If we have enough power from the repeater to be able to drive the coax antennas, we're reducing the number of points of failure, which is extremely important, right? And so a passive would be very straightforward with the repeater donor, again, the 2-hour enclosure for fire protection down into a signal booster, and then antennas and coax coming out from there. And there's multiple manufacturers out there on the repeaters that have done a very good job, again, all needing to be FCC certified.
Thank you, Brian. The second question is, do you happen to know, based on available iBwave parts, if all vendors support these technologies?
I'll take that one. The information that we have in our publicly available iBwave components database, which is online and free for anyone to use, the parts that are modeled in there are based on the information that we receive from our suppliers. If there is information that is not in there, if you have iBwave Design and Unity or Unity, you can access the database editor and then update that information if you have information that's more up to date. But we do try and keep our parts database up to date with the latest information regarding compliancy. If something is missing, please let us know. We'll be happy to update those parts in the database and ensure that we cover that information.
Thank you, John. So the other question, with regards to building requirements, the code appears to infer it applies to all buildings, but we are finding that smaller buildings, that is less than 3 floors, are not requiring the code. Is there a threshold?
Right, so from the nationwide level of ISD and NFPA 72, there is no, to my knowledge, and if anyone knows otherwise, by all means let me know, but to my knowledge there is no criteria as far as building size. It's simply what is the AHJ enforcing. However, on the state level and certainly at the municipality level, there are some agencies that are tweaking that a little bit. And for instance, I know in Bellevue, I don't know if they've changed it, but it used to be at least, I think buildings had to be 35 feet or taller, and then there had to be maybe an underground level of some sort if there was, and it didn't matter about the 35 feet. And that's why it's important to have good relationships with the Fire Prevention Office, the local municipalities, because they will let you know if there's any other emergency responder radio coverage mandate or ordinance that needs to be applied as well.
Thank you, Brian. So another question is, could you comment on requirement on conduit and how many hours of rating?
What was that last part on? How many hours of what?
Of rating.
Of operating. Okay, so for definitely 2 hours is for the vertical riser. What we're beginning to see is we're seeing some AHJs actually enforce 2-hour rated for even some horizontal cabling, particularly in parking garages. And so, again, it's basically whatever the AHJ is going to enforce is what needs to be done. It becomes very difficult from a contractor perspective. I understand, you know, on bidding on these deals. So it's very clear, you need to be very clear as far as what you're providing, and if there's any additional requirements, that would be addressed either as a change order, or you discuss it with the developer or the GC, whoever you're reporting to. Again, having that permit and having that design submitted for permit is really important. That way you're identifying where the 2-hour conduit will be and where it will not, and then you can have that discussion if it doesn't meet their requirements.
There's another similar question. Would first responder cabling being run within a 2-hour rated room or area, staircase for example, require an additional 2-hour rated enclosure?
Not sure that I'm following the question on this. So they're asking if there's an additional enclosure necessary if it's in a 2-hour rated room?
Yes.
Okay, so right, as long as it's in a 2-hour rated room, our experience so far has been that no, the 2-hour rated room would be sufficient. I should probably give a disclaimer. This is not professional technical advice. by all means, everything has to be run by an AHJ when you're submitting your design, so please do that. But from our experience, as long as it's within a 2-hour rated room, that has been sufficient for approval.
So another question is, has DAQ acceptance testing been more defined in the new standards?
So DAQ, to my knowledge, as I recall, is not addressed in the 510, but it is addressed in the NFPA. And for the 2016 code in particular, I don't know if I referred to this at the beginning of the webinar or not, but it is section 9.6. If everyone wants to do a search, you can certainly find it. It's section NFPA 1221, section 9.6. And within 9.6, it does deal with the DAQ, and all it simply says is that a DAQ of 3.0 or better, both for analog and digital sounds, must be necessary. And basically that means it needs to be decent communication. That there's very little breakup. It's easily understood and comprehended both by the one speaking and by the one receiving.
Okay, thank you very much. I think that's all the time we have for questions today. And before we go, we also had some questions about the recording and the audio and the presentation being available. So I would just like to say that it will be available to all who have attended or registered for the webinar, and we will send it out by email within the next few days. Also, we have an iBwave in-building community on LinkedIn. So if you would like to post more questions or continue the discussion, I would like to invite you to join that community on LinkedIn. And lastly, I would just like to thank our presenters and thank you everyone for attending. And
thank you very much all for attending. Thank you very much, Brian, for dialing in from the West Coast. We really appreciate your support.
Oh, my pleasure. Thank you very much.
And don't forget to have a look at hetnet.com if you have any questions for Brian. Thank you all.
Thank you, everyone, and we will now disconnect the call. Have a good day.
Thank you.